Welcome back. This is the final part for our one challenge to recap all challenge. So this one here, it will be really insane. So what we are going to do right now is we will make this challenge a little bit more complex than it is. So therefore, if you can use base64 methods to get an easy way, go for this. Absolutely. Do not make it more complex than it is. But in this challenge right now, we want to have a look into writing more complex Smiley code and insert it into an existing application. So we will use not in base64 encode to string method, we will write an own for loop where we iterate over this array and print out every single value. Maybe we will also append them to an ASCII string to print it out directly. And beside this, we will also have some UI interaction. And this is really not an easy task because within the AES function where we are going to inject our code, there is no UI interaction. And we have to create a connection from the UI to this one over here to display some text or some messages. All right. So it will be really insane. And I guess this is an absolutely perfect final to finish our Smiley journey over here. It will be a little bit intense, and it could be also the case that it's a little bit overwhelming because we are going to do much stuff right now. But I guess it's better to finish in this way instead of just increasing the things we have learned so far. So therefore, let's do this. Let's jump into this right now. Okay, so we are still working on apps, one challenge to recap all. Let's remove the old directory that we do not have interference with old projects. And now let's have a look. JDX-GUI, AES APK. Let's see what we want to do. Okay, we go into COM, app hacking, AES, AES crypto. So we are still working on this one, and let me enable my pen quick. All right, so here we have the original code. Then let's see over here. Yes, here we want to insert our own code, and then once again we have the original code. Okay, so this is our task, and I mean it's exactly the same like the last one, beside the fact that now the code is a little bit more complex. So we are not having just a few Smiley lines, we have tons of Smiley lines. And therefore the transition, and let me clean this. So the transition from the original back into the original might be a little bit more complex. Beside this, what we also want to do is, let's see, within the main activity over here, and let's clear the screen. Okay, within the main activity, we have some sort of layout. So this is our AES crypto layout. So the one with the base64 encoded output. I simply blend it in right now. So this is an activity, and this activity is able to display things on our screen. Within our AES crypto function over here, we do not have the ability, but we want to have it. So we want to insert our code over here. And we also want to have the ability to print something on our smartphone. So here's our smartphone, and we want to make some text appear. And this means we need some kind of interaction between the AES crypto class and also the main activity over here. So our code transition is not just based on one class right now. We will make a code transition into another class over here. And this is freaking amazing. It's a little bit complex, I'm not gonna lie. But I will show you how we can do this, and then you have, yes, I mean, you already have unlimited power. You might not realize it right now, okay? So this is what we are going to do right now. And therefore I would suggest, let's start. We start once again with prototyping our application in the Android Studio to see if everything is working correctly, and then we paste it in here. And the second part will be about this interaction between activities, or let's say between a class, because this one here, it's simply just a class. It has no UI components available, but we will make it happen that we get an interaction with an UI component over here. And then we can also display some fancy things on our activity screen of our original application. All right, so therefore, let's open Android Studio. New terminal, tools, Android Studio, bin, bash, studio.sh. A little bit complex, you can also add it to your path environment if you want to, but I keep it starting in this way. Okay, now we create a new project. We do not want to mix them up right now, so let's keep them separate. Empty activity. And now let's see. This is now our Smiley support a hard way. I still go back to Nougat. Yeah, I guess that's a good compatibility. Yes, my smartphone is running higher, but we keep it to Nougat. And I keep Java over here. Alright, so now the Gradle process has been started and this might take a while. So I see you after this has finished. Alright, so the Gradle build has been finished, and in the last video we did insert our code over here, which is absolutely fine, beside the fact that we have here a little bit more components available that we do not have in an original application, but we will get to this later. So I guess it's really a better solution not to write it into the main activity, to write it into a separate class, if this class where we want to inject has no other dependencies also. Alright? I'm sorry for this, blame on me, but yeah, this time we will do it in this way. Okay, so we want to have our secret key, this one over here, and then we can iterate over this byte array. So therefore, let's first get these 3 methods. And now we create once again a new Java class. So simply, sorry, this was a little bit fast, right click, new Java class, AES. Okay, and now we also create a method, but this is the name and things like this are not relevant. We call it the same encrypt message, but we're not having a parameter in here. Okay. Oh, we need a return type, void. So here we have now our code. So Alt Enter to import those classes. Alright, and get instance, we have to surround with try and catch. We could also an exception signature. This means when we call this method has to be in a try and catch state. I guess let's do it this way. So it's also perfectly fine in this way. Alright, so now we've got our key, and to get the byte array, we need to call the method key get encoded. This is returning back our byte array. Perfect. Now we should assign this to a byte array. So therefore byte, and we call this byte array to get a little bit of diversity right now. Okay, we assign this to the return value over here, which means this gets assigned, which means our Smiley code has this move result object also in there. Okay, if we now want to print this byte array out, we could do it in the following way. I mean, base64 is the better approach, but let's say we make it, yeah, we want to write our own code. So therefore, for int I is equals 0, I is less than the byte array, and we have something like length, perfect, I plus plus. Okay, and then we could use something like system.out print line, and then we call byte array with the index. Yes, so this should work, I guess. Let's see. I mean, we are prototyping over here and we can experiment around with this one. So to call this method right now, we have to create a new instance of AES, and then we call encrypt message. And we have to do this in the main activity because this is our entry point, and this is where the code gets loaded in the onCreate. Not loaded, executed in this way. So we are having AES equals new AES. And then we want to call AES encrypt message. All right, and now you see we've got this, this unhandled exception because we've got it over here, which means we need to include this in a try and catch, I guess. Alt Enter. Surround with try and catch, perfect. But now we do not have this stuff, this try and catch stuff in our AES code right now. All right, let's select our device. Already selected. Let's run this application. We do not have to observe the graphical output. All we need to do is have a look into the logcat if we get printed out our byte array over here. So the Gradle build is still running, and now it's loading install already. Logcat, let's see. I'm not seeing anything so far. Do we get an exception? Let's search for system out. There we go. Okay, these are now these bytes. So this is already perfectly working for us right now. That's good. But let's make this a little bit more convenient. So for example, let's get this typical hex representation, 1 byte at a time. How can we do this? We've got something like a string format for this task. So we could use string.format, and then let's see, we have to use something like percentage or 0x, this is the ASCII string we append at the beginning. So everyone has an 0x. And then we want to have percent 0 to x. Yes. Okay, this bracket should be closed over here. Yes, so I guess this works. So now we are printing out 0x and then hex representation of 1 byte as 2 hex values over here. And the 0 is, if we're having a 0 in front of our hex value, it will be also displayed. So let's see and run. Perfect. This looks absolutely perfect. So I mean, we are getting a new key every time we start this application, but we can see, for example, here we've got this leading 0. If we remove this one over here and run it again, then there should be something, a placeholder or nothing. Okay, there's nothing in here right now. So that's the missing 0 and we want to include it. Okay, I mean, this looks even better right now, but let's take it to another level. So let's write all of this into a single line. Yes, into a single line. Okay, a string, this is our key string. All right. And now we need to get this. Let me see how we can do this. Okay. First, we need to append key string with the current values from this one over here. Yes. Okay, what's the problem? Okay, we need to initialize it. Let's initialize it with 0x, then we've gotten leading 0x, and then we've got our values over here. Yes, and we want to have these values in this format, so we should take it in this way. Yes, this looks good. So the 0x can be removed, and then we want to print it out, but not in the for loop, and just afterwards. Okay, so now we are appending every single value here. AF C8 14 into a string. The string has a leading 0x and here we are printing it out. So to make this, let's see if this works. And run app. Perfect. So now we've got our string as an ASCII hex representation over here. This can be easily used in any AES encrypt decrypt function right now. Awesome. But one thing, we do not want to search all system outs because there can be a lot in there. Let's add some identifier. So for example, this is our crypto key. Okay, let's make this a bit larger that you've got it all in once. All right, run app. Yes, this looks perfectly fine right now. Okay, here we have now our crypto key. I mean, at this point, it would be even enough to transfer this into the original application, into this one over here. This one, because I guess these lines of code will create a lot of Smiley syntax. We do not need everything. I mean, we dive in over here. Secret key, generate key. This is what we've got in the old code also, in the original code. Yes, it's this line. And then we have to add everything underneath. This has to be added over here between those two lines. All right, but now let's go the insane way. And the insane way, I would like to show you what I have planned for this. Let's see if this works out. I'm not sure about this. Okay, so we can create text messages on our screen. I will show this here. And toast, then we can call make text, and we've got 3 parameters. The first one is the context, and this is the hardest one. Then we've got our string, char sequence, for example, and then we've got the duration, how long we will display this string. So let's see, make text. Now the first parameter is the context, and how can we get the context, or what is the context? An Android application, if it has a screen, the screen is the context, so the current activity, the main activity, which means if we want to print out some text on our screen, the application needs to know where or what is the current context, what is the screen where I should put this text onto. So therefore, in our case, we want to have it on our main activity because we need some sort of graphical output for this one. Or let's say an activity which has some graphical components because we've got an onCreate method. Therefore, we're creating a layout. So the context is simply just telling, I am now on the main activity. Please print this out on the main activity. And therefore, we also have a method which is this. So that's the main activity, get application context. Okay, now this toast message knows, all right, I need to be printed out on the main activity over here. So this is the activity which is in the foreground and I need to be printed out over there. All right, perfect. So let's see. Hacking into your application, this is the text we want to show. And then we've got the last parameter, which is the length. And we've got predefined values, length short and length long. I mean, short is pretty enough because we just want it to be displayed, just a few milliseconds. All right, let's run this application. And then, oh yes, I have missed something. I always keep missing this. So this is now just creating the text. If you want to show the text, we have to call the .show method. So yeah, this happens all the time to me. Let's run this once again. And then I get back the screen that you can also see what's happening there. Okay. So screen copy. Screen copy is interacting with the ADB and you can see it's killing this connection right now. And yes, something. Okay, this wasn't mentioned, so let me unplug this real quick. Okay, I haven't thought that screen copy goes that far, but let's see. Okay, we've got an ADB shell, now it should work. Yes, this is why I would like to install it first and then play around with this, because it could be even worse. So let's see. Yes, this application has been already launched and this message has disappeared. Let's see. Let's relaunch it. Oh, I guess it's this one. Yes. Hacking into your application. Have you seen it? Maybe select long, then it's a little bit longer. I guess we can also provide time values, for example, 2 seconds or yeah, maybe more. So let's see. Okay, there we have this text. Is there a typo? No, it looks good. Okay. So this text is also something we want to inject into the original application over here, this one. But now there's the hard task. So let's take this code and paste it into, for example, at the beginning where we want to have our transition over here. And then also maybe at the end. And then and check the ADB logcat output. And here we can already see this class over here has no such context. So this has no context where it can print some text over there. And what we need to do is we need to inject now code into the main activity also. So we need to get this context as a static value and then we can use it over here. And this is the transition we also want to make in this application over here. It's the same approach. We need to inject a little piece of code into the main activity and then we've got a constant or a static value from the context which can be used in our code over here. And this is freaking awesome because we can also perform UI interactions. So if you present this to a customer when you have hacked this application and there's some fancy stuff going on, I mean, this is absolutely perfect. All right, so let's do this. Okay, how can we do this? I mean, it's a little bit of Android programming right now, and this topic, this context, it took me quite a while to understand it. I tried to explain it and I hope it's a little bit faster for you. So first we need to create a static variable, a static context. Okay, then we need to import it. Okay, now in the onCreate method, there we have the access to this context because the onCreate method is creating a screen layout, and this screen layout has a context. So this is something where the application can reference to, okay, I need to be printed out over there. So let's assign this over here. The context is equals to this get application context. All right. And now we can use this context because it's a static field. We can use it in our AES method. So we can reference it now in the following way. Of course, we need to make sure that we have established this context correctly. Otherwise, this would crash completely. So main activity dot context. But we will make sure that we establish this context because this is the code. This one over here, we are going to inject into the main activity also. Over here, just underneath set content view. There we are creating a new static field and we will reference it in our code afterwards. All right. Okay, so let's see. Now we're having the context. It's working in this way right now. This text needs to be printed out on the main activity. And now I would suggest let's simply run this. So we are not having it in the main activity anymore. This is now within a class that has not directly access to some graphical output. So we run this. Okay. And over here, yes, we can see perfect. It's working in this way, but it's a little bit more of effort. So beside only injecting into the AES class, into this one, we also have to take care about the main activity, but we will handle this. This is absolutely no problem for us right now. I mean, it might be harder to write this code over here to understand that it's working in this way. But patching it for us right now, absolutely no problem. So therefore, let's build this application. Build APK. Then let's see, locate, okay. And now we are taking a first look into the code. So let's see how many lines of code we have produced in here by creating this for loop, those system out, those toast messages and things like this. APK tool D, app debug. Okay, and now let's open this with Visual Studio Code. So we are within Smiley classes 2, com, app hacking, and then let's first have a look into the AES class. So here we have the AES class, let's select Java. And now let's see, where do we have it? Here we have this encrypt message and generate key. This is the last instruction we have copied from the original application, okay. And then, okay, yes. So this is our code right now. I mean, this is intense, right? So we need to make the transition. Let's write this down. Beginning of our own code. From here to here. Yes, this is where it ends. Okay, this whole code, this code needs to be placed into this application here in between. I would suggest let's first do this, and then we will have a look into the main activity, how we can adjust this patch right now. And then we make sure that the transition is working absolutely smooth from the original code into our code back to the original code again. That everything we might overwrite or we might reassign will be patched probably that it works correctly. So everything we keep overwriting over here needs to be restored or needs to be circumvented in a certain way that we can, that we are not messing up some existing code. This is no problem for us. We will do this in just a moment. Okay, so first let's patch this code. And therefore we go into apps, one challenge to recap all, and now APK tool D, AES APK. Please make sure that we're having a clean new state, because if you're working on this one, this will be a huge mess. Okay, so here we have it, code AES. We're opening this with Visual Studio Code. Okay, also my PC is absolutely hyped about this one and the fan is spinning crazy, therefore I have moved the mic to the other side. I hope it's a little bit better right now. So here we've got our Visual Studio Code, so let's see. Smiley classes 2, com, app hacking, AES crypto. So this is the original application. Let's enable Java. And then here we have encrypt message, and let's see. Secret key, generate key, line 21. Let's verify this real quick. Secret key, generate key. Exactly. This is line 21, so we will insert our code afterwards. Yes, in between those two. Okay, let's do it in this way. So now we go into our compiled code. Oh, this is the app debug. It's this one. And we copy this one, this part. Yes. And we select those two and insert it over here. And then we've gotten perfect insertion into this existing code. Alrighty, this looks good. It looks intense, but it looks good. Okay, this is the first thing we need to do. And now this one over here, these are things we need to adjust. So this is now the reference, the context from our code over here, from this activity. And this context is being referenced by the package name. So we need to adjust this to the original package, of course, which means this part, com app hacking smiley support hardware, this activity is not existing. This activity over here, let's see, what's the name? Main activity. It's this one. Yes. So we need to adjust those two lines, but let's not, whoops, sorry. Let's do it not right now. We will take this to the graphic tablet and discuss this over there. Okay, so beside this, we also need to apply our patch into the main activity. So over here, we've got this main activity. And what we need to insert here is the following. Let's put them side by side. So we need to insert this part, line 13. We need to insert it after the text view, for example. And we need to insert this part directly after the set content view. Yes, before we start initializing this text view. I mean, we could also use the existing text view to print out our text right now. But yeah, I mean, I guess this toast message is a little bit cooler. In case if you want some additional modifications and you stuck at a certain point, write me a message. I will drop a bonus video if there's a lot of response regarding to this one. All right? Okay, so let's see. Those two lines, let's see. Line 13 in our app code. Let's also put them in this way. Okay. So let's close the Explorer on both sides. There we go. And let's enable Java. Here we have it. Here it's missing. So now main activity, we need to go into our main activity. And this is over here. Okay. Let's enable Java. Left is the code we have written. Right is the original code. So let's see, line 13. Was it 13? Yes, it is line 13. I'm not sure if we are having a correct line reference right now, and it seems like it's not the case. Yes, and therefore do not rely on line numbers. So we can see we've got a static field over here, and this is missing over here. So simply let's copy this static field into this part. Okay, beside this, we've got P0. So here we can see P0 is being used as this object. So if you're having an activity like this one over here, we are using P0 most of the time as in this object. If we are not having an activity, if we just have a simply pure Java class, then P0 might be reused, like we have seen it in some few examples over here. And just as a node. Okay, and then we've got this one over here. Here's set content view. Maybe let's enable word wrap, then we've got it in one line. Yes, and all we have to do is this. We have to copy paste this one on the right side. Yes, after set content view. So this is the only adjustment we have to take. Let's create some space. Begin. End. So now let's take this one here and let's replace it in here. All right. And now the last thing we need to do, yes, we will take this to the graphic tablet. Okay, one thing we need to adjust over here is the package name for our activity, because this one is from our code and therefore it will be referenced as com, app hacking, Smali support hardware main activity. So this application would look up in this directory if there is a main activity. And if we go into this directory, let's see how far we can get. Not even close. We've got com, app hacking, AES, and we're already out because we are not having a Smali support hardware package right now. Okay? But we do not make this modification right now. We will take this to the graphic tablet, and there we have a transparent view on the things we have added, where and why, and we will also keep track on what we need to do to adjust this in the original application. Okay? Okay, so let's take this right now. Not this one. This is now gone. We do not care about this anymore. This is completely gone. So let's take this file first. This one over here to the graphic tablet. Then we will have a look into the main activity and we will discuss all the things. I mean, we do not have to go through every line because this would take quite a while for this part over here. We just want to make sure that the transition from the original code into our code is correct. And therefore I would like to show you some neat tricks that can be super handy to perform this task. And also, of course, outwards. So from our code back into this application code once again. Okay, so let's start. Let's do this. Let's take this to the graphic tablet and I see you in just a moment. Let's go. All right, so here we are back on the graphic tablet and this method is absolutely massive. So let's scroll down. Here we have our beginning. All right, so we need to understand a little bit of what's going on over there to make the transition from the original code into our code and backwards, but we do not need to know every line. In case if you want to know every line, write me a message. I will drop you a video where we go through every line step by step. Okay, so for now, let's speed this a little bit up. Okay, here we go. We've got our method encrypt message. Okay, this means this is the original code. Here we begin with the original code and it ends up over here. Okay, this is the first part. Then we have the second part, our code. And this begins over here. And now let's see. It goes, it's even not visible. So let's start drawing already. Oh, well, it goes down all this way till here. And then over here, we have the transition into the original code once again. All right. So let's see. Okay, let's start analyzing this. And we will do this in several steps because otherwise we will run out of space right now. So the first thing we want to make sure is which register are being used for what in the original code over here in this part. So this is the first thing we want to know. Let's see. The easiest way is to go backwards. So we can see v1 is being initialized over here. And let's write this down. v1 is equal and v1 is the return type over here. So this will be stored in v1. So based on the last instruction we know v1 is JavaX crypto secret key. So v1 is our secret key. Then if we have a look into v0, this is the last time we do something with v0. And the amazing part in Smali is all those type references are next to us. So this one, v0, is our key generator. v0 is our key generator. All right, this is all as far as I can see right now. Let's do this, AES. Oh yes, of course. One important thing which is missing, the parameter. This time we are not extending an activity, so therefore the this object is not reserved for the P0 register. P0 is now our parameter. P0 is now our parameter. So it's plain text, but let's keep it parameter. And this one is from type byte array. Alrighty, now let's have a look how many registers we are using in the complete code path. So not just within our code 1, also within our part, let's call this 3. So this one over here is part 1. Then we have this code and over here we have the part 3. So this is the complete original application, part 1 and 3, without our code we have inserted right now. Okay, let's scroll down a little bit. There we go. So here we can see we got 5 local registers. So within both code path 1 and 3, we are using 5 local registers. We are using, let's write them down. V0, V1, V2, V3, and V4. We have already seen V0, which shouldn't be touched, and V1, which shouldn't be touched, because we need to, otherwise we would have to restore them in the third part. So these two are gone, V0 and V1. But V2, V3, and V4 are free for use, because they haven't been used over here. Now we have our inserted part, this one. This is our part 2. And within our part 2, we could easily make use of these registers, V2, V3, and V4. Because even if we assign and if we play around with them, they will be only used in part 3, which means, let's say we assign V3 to some 0x0 register, this would be overwritten over here once again to something more important. So therefore it gets recycled and we are not using it anymore. So therefore those 3 registers are free for use right now. All right? Okay. One neat trick I would like to show you is, you already know this, but I mean, seeing this in an example like this one makes it a little bit more clear. We will immediately increase those registers because we do not want to play around with a lot of reassigning. We want to have freedom, and maybe we already use higher registers. Let's see. Yes, we are using V9. All right. This is a very high register. So therefore, let's go beyond every limit. The maximum amount of registers we can use are 16. So therefore we can increase this value to 15. Which means beside those 3, we can also use those registers from V5, V6, V7, V8, V9, 10, 11, 12, 13, 14, and also 15. These are now all registers which are free for use because they haven't been known in this part right now, in this one or this one. These registers know only values from 0 to 4, which are 5. But now we have introduced a lot of more and they haven't been known before, therefore they are absolutely free in our code part. All right? Okay, so far so good. Now let's clean this up a little bit and let's take the most important parts out of this one. So I will write them down a little bit more clear right now. Let's give me a minute for this. Okay, so here we have it now. We've got an overview about the free registers, we've got our own registers, and we've got the ones that has been already set up. And let's draw this line, the thin line between the original code and our code right now. Okay, what we need to make sure right now is that if we are using those registers, or for example those two, or also the P0 register, that they are being used in the correct type. So therefore, let's make sure that that's the point right now. So let's scroll down a little bit. Okay. Here we've got local 1, and local 1 will be assigned to key, which is secret key. Okay, so let's do this right now. We start over here at this line. And here we can see local v1. We already are, we are playing around with an already set register. This one is from type secret key, and we can see, yes, this is working probably. So v1, let's write this down. v1 is from type secret key in our code. This is correct. So we are reusing this one correctly. Then we've got v2, and here we can see v2. This is now a thing we need to write down on our to-do list. So v2, we've got sget object, and we've got this context object right now. So this is our context object. Okay, and this will be fetched into v2. So v2 is our context. This is absolutely no problem because we can see over here v2 has been free. Maybe let's deny this right now. So we shouldn't reuse v2 in another state right now. Until, of course, we are not using this context anymore. Okay? So yes, this is this part, but we can see this is something we have to adjust. So there is no package Smali support hard way. And therefore, this is something we need to do. We need to adjust this in our application code. And this needs to be adjusted too. Let's see. Maybe we can see this if we scroll up a little bit. No, we cannot see it right now because we have no activity context right now. I mean, it should be com app hacking AES, com app hacking AES, and then we should have an main activity. But let's verify this. Package name. Okay. So in this way, we will not miss it later on. And then let's see. We've got const string v3. So v3 will be in string. So far, so good. Okay, next we've got v4, and v4 will be assigned to 0x1. And this could be everything. This could be an integer value. This could be a Boolean value. We just know v4 is being assigned to 0x1. Okay, let's recap this a little bit. We are using v3 right now. Okay, it has been free, and also v4. All right. These are all registers that has been set up in the original application, and we can see our transition is now working properly because everything else underneath this code should work out beside our to-do over here. This is something we have to observe a little bit, the v2 context part. But the rest should be probably fine. There's a dot missing. Now it's a string. Okay, so let's move on just a little bit right now. Okay, here we've got now, we are at this point right now. So let's maybe also draw a little bit of a line that we notice. Okay, we are here right now. So we are invoking a static method. Oh yes, now we need to get back to purple or something that looks like purple, this one maybe. And we have now our UI interaction. So Android widget toast make text. Okay, this is fine. That's the Android toast class. Nothing we need to adjust over here. And now we've got 3 parameters. Now it's getting interesting. The first one is this part over here. So let's try to skip it in this way. Okay, this is v2. Let's see. v2 is context. This is correct. We can see Android content context. Perfect. What are those other? Then we've got Java-lang jar sequence. This is this part over here. This is v3. All right, v3. Yes, we've gotten string in here. Perfect. And last but not least, let's see. So this one over here. Okay, this is an integer value. It's v4. So yes, now we know this is an integer value. Let's write this down. Integer value. And this is 1. So this is also working properly. And then we get back this graphical UI. So we write this down, this toast, into v2. Okay, this means at this point we are overriding v2. v2 is now our toast object. So therefore v2 is overriding this part. But this is absolutely fine because we are not using the context anymore. So therefore, if we scroll down a little bit, let's see. This context, nope. No. Okay, I cannot see it anymore. Maybe we dive a little bit deeper into this, but I guess this is now the transition where everything is working probably fine. We have tested our code works, and now we are within our original registers without having overwritten anything so far. We should take care about v0 and v1, that those two are really not being overwritten, and also this p0 object. So this is a real danger approach. We need to take care about them, but the rest looks absolutely perfect fine. Okay, so let's change the color to make sure till here everything is fine. Okay, then we call the method show. So here we've got our toast, make text. Then we've got our 3 parameters, v2, v3, v4, dot show. Okay, so this is this line of code. Next, let's see. We are overriding v2 once again. So our text has been shown. Therefore, we can also get rid of this toast message. Here we are assigning v2, this toast object, to another string, 0x. Okay, we are reassigning v2. Okay, this is now working properly. The only thing I would like to do is keeping track of these types. So for example, let's jump in between over here. This one, for example, new array, this line. Let's see if everything is working correctly over here. If this is the case, then it's probably most likely that this code is working so far independent. So we do not need to adjust anything right now. In case if we have a mismatch regarding to certain types, then of course we have to take a look. But we do not need to go the whole code. We just have to focus on these values. So here we're creating a new array and we're creating it into v7. And this one over here, let's see, what's this one? I'm not familiar with this instruction totally, so therefore I would like to look it up. So let's have a look into new array. Okay, here we have it. New array, vx, vy, type ID. Generates a new array of type ID. Okay, that's the type ID. And vy, element sized, and puts the reference into vx. This is the amount of elements, this is the type, and we put it into vx. Perfect, let's get back. So this means we are creating a typical Java-Lang object array with the size v4, and we put this into v7. So v7 is our array, and the size is v4. Let's see where v4 has been used the last time. Let's see. It goes back a little bit. Okay. All right, v4 has been the last time set over here. Is this correct? Let's see. Okay, so we are creating an array and the element size is 1. So this is not the length of the array, this is the element size. And then let's see, we've got const v8, so let's write it over here a little bit. v8 is now being assigned to 0x0. Okay, next we've got a get byte, and this is something I also want to look up because I cannot memorize if we have this array and what's the size parameter and what's getting stored anywhere. Okay, so let's look this up real quick. Okay, here we have it. Gets a byte value of a byte array into vx. Okay, this is 1 byte into vx of our array. The array is referenced by vy. Okay, this is our array. And it is being indexed by vset. All right. Yes, okay. Let's write this down. So this instruction simply means we are having something like A9, this is our byte value, is being referenced by v3 and the index v5. This is what this line does. Let's see if these parameters are correct. We scroll up, okay. Where have we been using the last time v3? Over here. Yes. This is just the array length, so we get the number of elements from our byte array into v6. Oh, that's also an interesting point. We will have to look into this one, but then, yeah, we do not analyze everything, but this is a really important thing over here. So let me do this real quick. Okay, but first let's finish this one. Okay, we know v3 is being initialized over here. So maybe let's draw some lines. So v3 is being initialized or set to a byte array. Okay, and then let's see, what was the other parameter? v5. And we can see v5 is being set to 0 afterwards. v5 is being referenced as I. So v5 is our 0x0 and it's the reference variable I, which means, do we use v5? Nope, we are not assigning it. So this one over here it's working perfectly. This line means we are having the following. I will clean this up afterwards because otherwise it will get very confusing right now. So this one over here, v3 is our byte array, okay? And v5 is the index. So we are referring v3 index 0, and we write this into v9. Okay, this is also working properly. No type confusion or things like this. Everything is set up correctly. Okay, let's have a look into this part, but first let me clean this up a little bit, all right? All right, so far so good. Now, what's that interesting point with this one over here? So this line. Here we can see we've got a casual if statement. Let's see. If v5 is greater else v6, we jump to condition 0. So let's write this down. Okay, let's see where condition 0 is. Okay, so let's get it on screen. There we go. So we jump downwards here. So this is condition 0. Okay. So far, everything pretty normal. We are just skipping this code right now. And this code, this is now interesting because we've gotten go-to label over here. But where's this go-to jump? Did we miss something? I guess not. So if we scroll down, we can see, oh, that's interesting. Here there's this go-to label. So if this one over here is not true, then we go into this block over here. And this block right now got an go-to at the end, and this go-to is referencing back to the beginning. So what this one over here is, it's our for loop. This is the for loop where we iterate over our array. And yeah, this is pretty amazing in my opinion, because this is how a for loop looks like. So we've gotten a label over here, okay? Then we've gotten condition. Let's see what are those parameters, v5 and v6. What are those? So let's get back a little bit. I mean, here we already see this. We do not have to go back. v5 is 0. v5 is being initialized to 0x0. And we can see v5 has been assigned to I afterwards. So this one is our I. Okay, this means v5 is I. This is our increasing counter variable. Let's see what's the other part. Let's take another color. The other part is v6. And v6 is the array length. So let's see what array length is doing. I mean, array length is taking, yeah, okay, I guess we can guess it, because array length is taking the length of our array into v6. Yes, in case if you are not 100% sure, you should definitely look it up. But now, after seeing this instruction, I can remember what's doing. So this means v6, and this part over here, this is our array length. And this is exactly condition we have here. If I is greater than our array length, then we jump to condition 0. So this means our counting variable has become larger than the array we want to iterate over. So we jump out to condition 0, which is here. If this is not the case, we go into this code and we will go through this whole code. So I will clean this up once again. So therefore let's write into this. So we go down into this whole code until we hit this line, this go-to line. And then we go back again. So we start over here. And then once again, we are checking. Our I has been increased over here. This part is I is equals I plus 1, or also I plus plus. And then it will be checked once again over here. Is I now bigger or larger than v6? Yes, then we jump out. Otherwise, we go back into this once again. And then we've got this jump backwards. Why is this now so important? Because this is something you could accidentally create. But this time we're having a break condition, which is this part over here. So this is our breakout condition, this one. So if we wouldn't have this break condition, so let's say this one has gone, it's not available, and we have played around with those jump labels. What's happening right now? We have created an infinite loop. This one over here, it's an infinite loop. The application will crash and you might search for this error quite a while. Because what's happening over here? So we jump to this go-to label. Okay. Then we go back into our code right now. All right. But then over here, we jump back to our code, to the beginning. All right. Then we go downwards all the way. And then we realize, okay, we need to go upwards once again and so on. So this is happening all the time. This is our infinity loop. So therefore, if you play around with these jump labels, make sure you're not jumping upwards, and in case if you does, make sure that you have a breakout condition that it's really leaving this code at a certain time. Alright? This is just a short note. It's not super important for this task right now. I guess it's just interesting to see how for loops gets constructed over here, and how you can accidentally create an infinitive loop. Alright? Perfect. Let's clean this up once again. Okay, I mean, so far so good. We can go to this part right now, because everything else has been already analyzed. Yes, here it's getting interesting once again. So string builder, okay, v7. Let's take a random line. For example, let's take this line over here. Is everything still working correctly? We've got v5 and v6. v5 should be in print stream. Let's see. v5 is being used over here. Okay, yes, here we've got a print stream. This is correct. And then we've got we are here. We've got v6, and v6 is now from type Java lang string. And we can see, yes, this is the return value or return type. It will be moved into v6, which means v6 is from type Java lang string. So these are aligning properly. I mean, it could be luck. It has to mean that there's no error in between there, but it's pretty unlikely right now. Okay, let's move downwards. Here we've got our toast. Oh, this one. Yes, we should observe this part right now. Okay, here we can see we are reusing or reassigning v5. We have used it just right before. v5 has been an print stream. Okay, so v5 is being recycled at this point, and it will be assigned to the context. So this one over here, this is the field type. Okay, so the field type is from context. Okay, and this time, once again, we need to make sure that we are not having this package name in there. So we need to replace this package name with AES. This is something we need to do. Okay, and then we're jumping out of this code. All right, so now we need to make sure that the transition outwards is also perfectly fine. In this case, it's an easy task because we can see secret key needs to be in register v1. Secret key. Okay, and v2 is being, we have already realized v2 can be anything else because it's being recycled. We have to take care about v0 and p0, because these were the only registers that have been set up before in our code, in the original code. This part over here. So v0 needs to be key generator, and secret key needs to be in v1, and p0 needs to be our parameter. So this is something we need to look down right now. So we need to get into our code and we have to look for these values. But as far as I can see, we are not doing something with v0 and also not something with v1. I mean, yes, here it's being assigned to secret key, but that's correct. And otherwise we are not using it. So let's scroll down. Yes, that's it. Easy peasy. v1 is secret key. Let's figure out if v0 is this keygen object. And p0 should be our parameter. Let's see if this is correct. So v1 is secret key, all right. Where do we use v0? Do we have it over here? No, I cannot see v0, so maybe this keygen object has already been recycled because it's not being used. After our first initialization, we are not doing anything with keygen anymore, and therefore it can be simply ignored. All right, the last thing we have to check is p0. p0, let's see. Yes, p0 is being used over here. Anywhere else? No. Perfect, we can see we are calling cipher do final, and this is our parameter. Our parameter is this byte array, and if we take a look into the original code, do final will be called with the original parameter, with this one. Which means the transition into the original code is also working perfectly. We cannot find keygen anymore, this key generator object in v0, but it simply has been recycled. It's not being used afterwards, and v1 is still being set to secret key. I guess we did an amazing job. So we got most of this stuff over here, and also the approach. I mean, it's pretty nice, right? We've got 2 to-dos right here, but we do not have to adjust anything else beside those 2 package names. This is everything we need to change, and then the code is working absolutely smooth. We have taken care about all those registers. We have seen the code is working correctly. Those types are working correctly. We haven't taken a look into a for loop. So this is a really, really nice wrap up of our Smarty task or Smarty journey we have already done so far. One modification is missing in this part over here. So we also need to take care about this one. To do. All right, these are our 3 to-dos right now. To increase the number of register and to change the Smiley support hard way. Let's do this right now, and then we will have a look into the main activity, or maybe we will see if this builds or if there are some errors in there right now, okay? Okay, so let's patch this first. Yes, we are in the correct method. Please make this also sure that you're not accidentally patching the other method. So first we want to increase these registers to 15, okay? I hope they are 16, but yeah, we will figure this out. Then this Smiley support hard way. Let's see what's the real main activity over here. So we go into main activity. I mean, this could be also something completely different. This could be some other activity or things like this. So it has to be the main activity. But this is the only activity we have in our application, and therefore we want to print it over here. So here we've got set content view, so we can take this whole part over here. Okay. And now we are searching for, let's see, there's some replace. Let's see how we can replace. Edit, replace, Control H. Okay. So we want to replace it with this way, and we want to replace this part over here. Yes. So can we make this a little bit larger? No, but it should work. So let's observe this really close and let's see if we can replace it. How can we do this? Okay, by clicking enter. So let's see. Com app hacking main activity, AES main activity. All right, this is perfectly fine. Okay, so we have increased those registers. We have adjusted those 2 patches. So let's build this back again. I'm super excited to see if this works. We're getting an error. This is already a label with that name. Ah, okay, yes. 252.4. I'm not sure if it's now this line number or this one, but we have problems with our labels. Those labels haven't changed right now, so we haven't changed these labels, which means we've gotten go to 0, or we've gotten condition 0, and I guess we have 2 of them right now. Let's see, condition. So condition 0, okay, condition 0 looks good. Let's see what's with go to 0. Here we have a go to instruction. Here we have, oh yes, here we have a go to label, and also here. So we've got now 2 go to labels, and of course the program doesn't know where to jump to our for loop or into the return out stuff. So let's adjust this over here. I mean, the easiest way is to provide our own label. Own label. Okay. And then we need to figure out the reference to this one, which is here. Okay. And this should be the patch. So condition 0 is, are we not using condition 0 anywhere? No. Interesting. Okay, cool. This means this should build right now. In case you could also, of course, adjust condition 0. But let's see. Nice. This looks perfect. So this part has been done. If we try to install this application, it will crash because we are not having this static context right now in our main activity. So therefore, let's take this back to the graphic part and let's do part 2. I know this video is already long. Sorry for this one, but I mean, it's a pretty amazing task, and we are recapping everything right now. We've got labels, we've got if conditions, we've got register types, values, new instructions, and yeah, and all these amazing things. Okay, we are now getting back to the main activity, and I will see you on the graphic tablet for the last task over here. Let's go. Okay, so here we have the onCreate method, and we can see we have added this code over here. And this is our code, which means green one is the original application code, and this one is also the original application code. And we do now the same approach. So we will figure out which registers are being used in this part, in the first part, and if we are overriding them in our second part. So if this is the case, we need to restore them in the third part. Or we need to circumvent this by increasing those local registers or other stuff. Okay, let's draw also our line, this line, the separation line, and then let's go backwards. So like we have done it in the previous example. Here we've got V0 and P0 already. So let's see, what is V0? V0, this is now invoke virtual, this is a parameter, and this is an integer value. All right, V0 is an integer value. And this integer value is this one over here. So V0 is being assigned to 0x7f null b, and so on. Okay. And then we've got P0. P0, let's see. P0, where we are using P0. I mean, we are using it directly here. So this one has to be the reference. Yes. This one over here is com app hacking AES main activity. So this is our main activity reference. So this is our this object, main activity, this object. Okay. Then what else do we have? We have P1 also over here. And P1 is our parameter. And this parameter is from type bundle, OS bundle. So I'm pretty sure we are not messing around with this one. Okay, so now we have to figure out if everything has been aligned correctly, and if we are overriding V0, if we can do this, or if it's still being used. So therefore, let's get into this one. Now our code. P0 in our code is also main activity, but this one is not correct. So here we've got smiley support hard way, and this needs to be replaced with AES. Okay, so this is our to-do over here. And P0 would be afterwards a reference to main activity. And this is the this object. And we can see, yes, this is working perfectly fine. Main activity, this, perfect, P0. Everything is fine with this one. Oh, but then it's getting interesting. We are moving the result into V0. So at this point, we are overriding V0. And what's getting moved into V0? We are calling get application context, and we are moving the context in this part over here into V0. So we are overriding V0. So we need to make sure that V0 over here is being used the last time in this method call, because otherwise, if V0 is being used in the next part anywhere, and we are overriding it with context, this will cause trouble. All right? Okay, so let's move on for now, and then we will verify this. Let's see if we have to do something else. And then we've got as_put object. So we are putting this object into the context. And this makes also no sense, because this is once again not this context, it's the AES context. So as_put object, the context right now gets put into main activity context context. Okay, so this will be put into the main activity context. Let's do it this way. And this is perfectly fine. So we are referencing this context to the main activity, this object. Okay, this is working properly. Now let's see. Perfect. In the original code, we can see V0 is now being used with another value, another integer value. So therefore, we do not have to restore V0 over here, because V0 is being overwritten at this part. Let's also make this transition line this way. So V0 is now being assigned to a new value. 0x7f080 and so on. Which means this is perfectly fine that we are overriding it at this point. This is okay, because it has been recycled anyway, one instruction after in the original code. All right, this is something I'm also not sure what happens right now. So let me point the problem out right now. Okay, so here we have our context. v0 has been set to the get application context. Where do we have it? Here. And then we are putting this context into this one, into main activity context. No, this is working perfectly fine. Sorry, I was a little bit too fast on this one. This is the static field. So yes, this is working perfectly fine. Maybe let's clear this up a little bit and focus only on this part right now. Because the transition over here, everything else is working correct. Okay, let's focus only on this part. So over here we've got main activity get application context. So this line looks like this. Main activity dot get application context. I will shorten this right now. And we're having no parameters, but we're having a return type from context. Let's make this purple. Okay, so this is the return type, or the return object in this case. And we were storing this into v0. So v0 becomes this part right now. Okay, so far so good. I guess this part is clear. Maybe not clear written, but I guess it's clear. So next, we've got sput object. And we are putting now v0 into main activity.context. So this context over here, which means we could rewrite this in the following way. Main activity.context, because it's a static field ID, we can reference it in this way, is now v0. At this point, v0 has been assigned and it can be reused like one line afterwards. This one over here. This is totally fine because we already have saved our context in this most important context field, which is our reference right now. All right. So therefore, everything has been working out correctly over here, beside the fact that we've got a Smiley support hard way. These are the only two adjustments, this one and where have we the other one, this one, we need to do right now. Let's do this, let's build back the application and let's see if this one works. If it does, I mean, this was tough, but you see, we have absolutely no limits. We could write a complete application over here and we could implement a whole debug server in this application which prints out those secret keys and yeah, do a lot of funny stuff. Okay, so therefore, let's go back, let's build this application and see if it's working. Okay, we have already inserted the code. Here's our context. And what we need to adjust is this one. So we need to copy this and we need to place it in here and also in here. Yes, we saved this and everything should be working correct right now. So let's see, I'm super excited to see if this works. Of course not, because we've got the slash in there. Where does the slash come from? Oh yes, I have made a copy-paste error, I'm pretty sure. Yes, we are missing our semicolon. All right. Yes, okay, nice. So we go into AES dist. Yes, and then we zip align this application. We sign this application. We uninstall the original one. Okay, we have to plug it in. Okay, let's see. There's our ADB screen copy. This is support hardware. Yeah, we do not care about this. We have now patched this AES application. All right, and now let's see. Let's install it. Yes, we kill the server. sorry, it's out APK. It's test only package, so -t. And let's get screen copy back again. Okay, let's keep this in foreground and let's open also the ADB logcat output to see if everything is working properly. So therefore, let's close these. And we are grabbing for crypto. Okay, maybe crypto key. Otherwise, we might get some other crypto stuff. All right, let's see. 3, 2, or maybe what do we expect right now? We expect our toast message and this amazing fancy crypto key string as an ASCII value over here. All right, so let's do this. 3, 2, 1. Amazing, hacking into your application. And done. Check the ADB logcat output. This is freaking awesome. It doesn't look this amazing how it feels like right now. I mean, we have made a transition from this activity into our patched code and back again. So we have applied our patch that we get this amazing key over here and can also interact with the UI components. So we could also print out something else. We could insert a whole activity in here. So our own defacement or things like this, but I'm not a fan of those defacements and stuff. Maybe regarding to a customer presentation, we could do some even more fancy right now, but this is pretty tough because we have set up everything correctly that we can do whatever we want right now. We could also interact with services, content provider, broadcast receivers. We could insert whatever we want. This can come super handy if you work with multiple colleagues on a project and your colleagues do, for example, the web application pen testing part. Let's say the network traffic has been encrypted once again with an AES, not just SSL, it has been encrypted with some keys. And those keys might change all the time. So you could now write this and send those keys to your colleagues on a web server automatically every time you start this application. So you have absolutely no limits anymore. You can write a whole debug server in this application and start debugging it. Everything is possible and now we know why. So Smiley is this is an absolutely ninja skill. All right, so far so good. I would say this video is now pretty long and therefore we cut it over here. In the next video, we will do the solution for the other parts regarding to parameters, return type, and also the initialization vector. And we will figure out how we can use this key to decrypt this message over here. All right. So this would be the last part before we go back into our black belt challenge. But in case if you want to skip this, feel free to do so because the most important stuff has been shown in this part already. All right, so I'm really looking forward to see you in the next section.